Okay, welcome to this second video on logarithms, where we're actually going to be talking about natural logarithms. So, what is a natural logarithm and how does it differ to our normal logarithms that we were talking about in our last video? Well, the difference for a natural logarithm is that we're talking in base e. So, over here, we've got the log to base e of x can really be written as ln, or natural logarithm, of x. So what are some of the rules? Well, they are exactly the same as our previous logarithms, where we've got ln m plus ln, which is our natural logarithm again, n, that's meant to be an n, is equal to ln m times n. And same with our, when we take natural logarithms, it's just equal to ln m over n. And also our final one, which was mln b, is just equal to ln b to the power of m. So it's worth noting that in our calculators we do have a log button and we have a natural log button. We should use natural log, the ln button, to work out these, not our log button. It's also interesting to note that if we have the following, we've got our natural log of e to the power of x, this is just equal to x. And similarly, if we have, and let's take it as an exponential, e to the power of ln x, that is just equal to x. So let's look at a couple of examples for this and we'll see what we can come out with. So an example might be if we've got natural log of, let's take e to the power of 5. Well, this is just going to equal, if we look here, ln e to the power of x, where x is a number, this is just going to equal 5. What if we have something where we've got to find, where we have, let's look at ln x is equal to 7. What is x going to equal to make this true? Well, we could just say, let's think about it like this, that we're going to have a natural log of e to the power of 7. Because that is just equal to 7. So in this case, we could say that x is just equal to e to the power of 7. So, what if we try to use our natural logs to solve an exponential equation? Let's say that we have, let's section this off. Let's say we have an equation that looks a little bit like 2 times 3 x to the power of minus 2 is going to be equal to 162. So what is x in this case? Well, this is where we use logarithms to work it out. So let's have a look. First thing we're going to do is divide both sides by 2, so we can get just 3x to the power of x minus 2 by itself, and we'll end up over here with 81. So we're going to have 3x minus 2 just equal to 81. Let's think about this for a moment. Is there a number that we could have raised to a power, or is there a number that we can raise 3 to the power of, like 3 to the power of something is equal to 81? Well, there is. We could go 3x minus 2 is equal to 3 to the power of 4. So what we've done here is we've rewritten each side with the same part here. So the same, we've got 3 to the power of something. Then all we have to do is just go solve for x like this. When we've got x minus 2 is equal to 4. In this case, x has to equal 6. So that's one way of solving it. We could also use logarithms, and let's do it that way now. So we'll start off same place. We'll start off from this point here because we need to simplify this as much as we can first. So we're going to have 3x minus 2 is equal to 81. Let's use logs. So we're going to have, if we work backwards from this rule here, we could have b to the power of m. Well, I've got 3 to the power of x minus 2 is just equal to m ln b. So let's work backwards. So we could take this x minus 2 term, so x minus 2 log of 3 is just going to be equal to the log of 81. Alright, let's go through now. Let's get these logs on the same side. So I'm going to have x minus 2 is going to be equal to the log of 81 divided by the log of 3. Now, like we've done in the past, if we work out that what power can we raise 3 to get 81, well, we know that that's 4. So let's go x minus 2 is just going to be equal to log of 81 is just 4 divided by the log of 3, which is 1. That is just equal to 4, so we're going to have x minus 2 is equal to 4, and again x is equal to 6. So we can do it both ways, using logarithms and by not using logarithms. We should really look at using logarithms to get used to using logarithms, and that should make a little bit more sense. So I'm going to leave it there for the moment with logarithms. We'll look at logarithmic functions later on and see how we can actually graph those. Again, if you have any questions about any of this, please don't hesitate to ask, and as always, thank you for watching.